In this problem, I can see the x's, the y's, and the z's are already lined up. And now I need to try to figure out what is going to be the quickest method to eliminate a variable. So no two numbers are the same. Okay, I see numbers are the same here. So my first thought is, yes, I could eliminate the y's or the z's fairly easy. Now I want to choose the y's over the z's because I can combine the first and the third equation and they eliminate easily. And the second and the third will also eliminate easily. So I'm going to choose to eliminate the y variables first. I'm going to write the first equation down, followed by the third equation. And I don't need to multiply the outside because I can see when I simplify negative 2y and positive 2y, they end up canceling, equaling 0. I add down to end up with 3x plus 5z equals 7. And that is my first boxed equation. Okay, now I've already used the first and I've used the third. I need to go back to the first three original problems and choose the equation that I have not used, which happens to be the third one. Okay, so I still need to continue with the idea of eliminating the y. So if I want to eliminate the y variable, will that be done easier when I combine it with the first or the third equation? And the answer is the third. So underneath it, I write down the third equation. Now I combine. And box it in. Okay, I'm going to take the two boxed equations and write one on top of the other. And at this point, combining them would not have any elimination of a variable. So 3 and 4 don't automatically eliminate when you add, and 5 and 1 do not eliminate. Does it appear easier to cancel the x's or the z's? So I'm going to multiply the second equation by negative 5. And the reason for that, I write down the first equation without adjusting anything. When I multiply everything by negative 5, I end up with negative 20x minus 5z equals negative 75. I chose negative 5 as a multiplier so that the z's would cancel out when you combine. Negative 17x equals negative 68. Divided by negative 17, and x equals a positive 4. So we're going to work ourselves back all the way to the original three equations. So from here, I work backwards to the two boxed equations, and I choose one of them that I think looks easier to work with. There is no wrong answer. So I'm going to choose to write down the second equation. And wherever I see an x, I'm going to input the value 4. Bless you. Okay, and again, we're just going to keep working our way all the way backwards to the beginning. So I've worked with the two boxed equations. Now I go up to the three original equations all the way up here. And you choose which equation you believe will be the easiest to work with. Remember, there is no wrong answer. I'm going to choose the last one. For an x, I'm going to substitute in 4. For a z, I'm going to substitute in negative 1. So I just broke the code. I need to write it in the order. Order matters. It goes X, Y, Z as my ordered triplet. What does this represent? It means I can take those values of X, Y, Z. I could plug them into any one of these equations for X, Y, Z, and the answers would appear as 4, 12, and 3. It also means that if I graphed these three equations, they would intersect at exactly one point. It would be the ordered triplet 4, 1, negative 1.